Adding and subtracting radical expressions. So when you're working with adding and subtracting radical expressions, we're looking with what's called like radicals, where your square root expressions have the same radicand. So an example of that would be, here we have 2 times the square root of 5 and 4 times the square root of 5. These have like radicals because they both have the square root of 5. The next one we have 6 times the square root of x and negative 2 times the square root of x. They both have the square root of x. So those would be like radicals. And the last situation we have 3 times the square root of 4t and 4t. They both have like radicals of the square root of 4t. Unlike radicals would be examples of 2 and the square root of 15, 6 times the square root of x and square root of 6x, 3 times the square root of 2, and 2 times the square root of 3. They do not have like radicals, so those would be, that's just showing examples of like radicals and unlike radicals. So like radicals can be combined by adding or subtracting. You can use the distributive property to show how this is done. So when we look at this here, we have 2 times the square root of 5 plus 4 times the square root of 5. They both have like radicals of square root of 5. So the way we combine this is we would add the outside numbers, 2 plus 4, and then the like radicals would be square root of 5. So 2 plus 4 is 6 times the square root of 5, and that would be your final answer, 6 times the square root of 5. The second example we have is 6 times the square root of x minus 2 times the square root of x. My like radicals are the square root of x, so we combine those. We'd also combine our outside numbers, so 6 minus 2 gives me 4 times the square root of x, and that would be my final answer. Let's do some examples of adding and subtracting radical expressions here. So for a, we have 5 times the square root of 7 minus 6 times the square root of 7. My like radicals are the square root of 7, so I would subtract 5 minus 6 to get negative 1 times the square root of 7, or negative 1 is just another way to state that as negative times the square root of 7. The next situation we have here is 8 times the square root of 3 minus 5 times the square root of 3. So we're going to combine my like radicals, square root of 3, and then 8 minus 5. 8 minus 5 gives me 3 times the square root of 3, and that would be my final answer. The next one, my like radicals are square root of n. So we have square root of n, and then we add the 4, so 4 plus 4 gives me 8 times the square root of n. The last situation here, we have the square root of 2s minus the square root of 5s plus 9 times the square root of 5s. My like radicals are square root of 5s, so we're going to combine those. So what we'll combine are the 5s's, and then we would combine the values in front of those like radicals. So negative 1 plus 9 we would combine in the square root of 5s. So my final answer is the square root of 2s, and then negative 1 plus 9 is 8. So plus 8 times the square root of 5s, and that would be my final answer. Example 2 here, they want us to simplify these expressions. So this is similar to breaking apart these values by finding perfect squares, by picking out perfect square numbers, and then simplifying it down. So for a, we have the square root of 54 plus the square root of 24. So we have to think of what factors, at least one factor needs to be a perfect square number. So 54 is 9 times 6, and 24 is 4 times 6. So square root of 9 times 6 plus the square root of 4 times 6 would break apart into square root of 9 times the square root of 6 plus the square root of 4 times the square root of 6. My like terms are going to be the square root of 6, and when we take the square root of 9, we get 3. So we get 3 times the square root of 6 plus square root of 4 is 2, 2 times the square root of 6. Now I combine my terms. So 3 plus 2 gives me 5, and then we combine my like radical, which is the square root of 6. So 5 times the square root of 6 would be my final answer. Here for B, we have 4 times the square root of 27 minus the square root of 18. We break this apart. For 27, we could break that apart into the square root of 9 times 3. For 18, we break that apart into the square root of 9 times 2. When we break this apart further, we have 4 times the square root of 9 times the square root of 3 minus square root of 9 times the square root of 2. We have no like radicals here, so what I'm going to do is we can take the square root of 9 and we get the value 3. So I pull that out in front, which is 4 times 3 times the square root of 3 minus 3 times the square root of 2. So notice how they just pulled out these perfect square numbers with the values in front. And my final answer is this. For C, we have the square root of 12y plus the square root of 27y. So we factor that out to get square root of 4 times 3y plus the square root of 9 times 3y. So that's square root of 4 times the square root of 3y plus the square root of 9 times the square root of 3y. My like terms are square root of 3y, and I can pull apart here the square root of 4 and square root of 9. Square root of 4 is 2, so I have 2 times square root of 3, plus the square root of 9 is 3, so plus 3 times the square root of 3y. My like radicals, my like terms are going to be my square root of 3y, and then I add my 2 plus 3, which gives me 5 times the square root of 3y, and that is my final answer.